Today we are going to do Math 6, Mission 8, Lesson 12. Lesson 12 is using mean and the mean absolute deviation to make comparisons. All right. So this is a mental math warm-up. You can take some time to try and figure that out. We're going to talk through the first one and then you can do the rest. So 42 divided by 12. Well, 42 is not a multiple of 12, but I know 36 is. So 36 divided by 12 equals 3, right? But then 36 and 42, that has a difference of 6. So 6 divided by 12 equals 0.5 because 6 is half of 12. And then I have to add those together. So 42 divided by 12 equals 3 5/10. 3.5. All right, you can try the rest on your own. Here we go. Task 1. Andre and Noah joined Elena, Jada, and Lynn in recording their basketball scores. They all recorded their scores in the same way, the number of baskets made out of 10 attempts. Each collected 12 data points. 12 data points. Andre's mean number of baskets was 5.25. So that's Andre's. And his MAD was 2.6. And remember, MAD is mean absolute deviation. Noah's mean, so we have Noah's, was also 2.25, but his MAD was 1. So we have a big difference in their mean absolute deviations. Here are the two dot plots that represent the two data sets. The triangle indicates the location of the mean. So here's our triangles. That indicates the mean. Without calculating, decide which dot plot represents Andre's data and which represents Noah's. Explain how you know. Well, they both have a mean of 5.25. So looking at the mean doesn't really help us because they're the same. But the mean absolute deviation is different. One is 2.6 and one is 1. So let's look at data set B. If I go 1 away from 5, or 5.25, excuse me, the mean, that should hit most of the data points if it's the right MAD. So here we go. So 5.25 would get me 1 away, would get me 6.25 up, and down would get me 4.25. I've only hit 1 dot if I go with a MAD of 1. So let's go up here to A and try that again. So if I start from the mean and go from 5.25 to 6.25, and then from 5.25 to 4.25, I have hit 1, 2, 3, 4, 5, 6, 7 out of 12 data points. That's quite a bit. Let's go down here and try this thinking with 2.6. So if I go to 2.6, let's see, 1.25, 2.25. So that's 1 up, then that's 2 up, and then I have to go 0.6 more. Ooh, okay, let's try down. So there's 1, there's 2, and then 6. That we have hit a good majority of our dots. So knowing that, I would say data set A has a MAD of 1. And who has the MAD of 1? The mean absolute deviation of 1. That's Noah. So I would say data set A is Noah, and data set B with a MAD of 2.6 is Andre. So, if you were captain of a basketball team and could use one more player on your team, who would you choose, Andre or Noah? Well, Andre and Noah have the same average, which means they shoot about the same. But if I were going to have to choose, I would choose Noah. I would really choose Noah because remember, MAD tells us variability. And the variability is the spread, how spread out those data points are, right? And so Andre has a variability of making only one shot or making 9, whereas Noah has a spread that's smaller. He goes from 3 to 8. So Noah is more consistent. So I would choose Noah over Andre. All right, let's go to number 2. An 8th grade student decided to join Andre and Noah and keep track of his scores. His data set is shown here. The mean of this student is 6. Ooh, so he is better, well, on average, he is better than Noah and Andre. All right, A says calculate the MAD. The way that we calculate the MAD is we decide how far away from the mean each data point is. Well, our mean is 6. So 6 is 0 away, 5 is 1 away, 4 is 2, 7 is 1 away from 6, 6 is 0 away from 6, 5 is 1, 7 is 1, 8 is 2, 5 is 1, 6 is 0, 5 is 1, 8 is 2. All right. Now, the way we calculate the MAD is to add up all of the distances from the mean and divide by the number that we have. So, we have 0 plus 1 plus 2 plus 1 plus 0 plus 1 plus 1 plus 2 plus 1 plus 0 plus 1 plus 2. And that equals 3, 4, 5. 2, 3, 5. So that's 5 and 5 and 2. So that's 12. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points. So we divide 12 by 12 and that gets us 1. So we have a MAD of 1 for this student. Draw a dot plot to represent his data and mark the location of the mean with a triangle. All right, so his lowest is 4 and his highest is 8. Okay, so I'm going to draw my dot plot and I'm going to go 1 lower than where he starts. So 3, 4, 5, 6, 7, 8, 9. All right. We have to put a dot for each one of his data points. So he has a 6 and a 5. So 6 and a 5. He has a 4 and a 7. 4, 7. He has a 6 and a 5 and a 7. So 5, 6, 7. He has an 8, a 5, and a 6. An 8, a 5, and a 6. And he has a 5 and an 8. 5 and 8. And then his mean was 6. So I'm going to, on here, on this, I'm going to put a triangle at the mean. So there is our dot plot. Compare the 8th grade student's mean and MAD to Noah's mean and MAD. So the 8th grader's mean was 6 and his MAD was 1. Noah's mean was 2.25. So Noah, his mean was 2.25. And his MAD, I'm pretty sure was also 1. Yep, his MAD was 1. So, oh, sorry, not 2.25. 5.25. There we go. All right, so compare the 8th grader's mean and MAD to Noah's mean and MAD. Well, they are both consistent, right? Because their MADs are the same, which means their variability is the same. So variability is the same. But the 8th grader is a higher scorer. He makes more baskets because his mean is higher. Compare their dot plots. What do you notice about the distribution? Okay, so let's look at this distribution. This one goes, whoop, and let's go up to Noah's. Noah's goes, whoop. So they have a pretty similar distribution. Right? And they have a similar spread. How do I know? Because their MADs are the same. Now, the 8th grader goes from 4 to 8, and Noah goes from 3 to 8. So Noah's a slightly more spread out, but not very much more. What can you say about the two players' shooting accuracy and consistency? So the 8th grader has a higher mean, so on average, he shoots more accurately than Noah. So that means he's more accurate. Okay. They have the same MAD though, so they're equally consistent. Okay, let's move on. Activity 2. In 1984, the mean age of swimmers on the U.S. women's swimming team was 18.2 years, and the MAD was 2.2 years. In 2016, the mean age of the swimmers was 22.8 years, and the MAD was 3 years. How has the average age of the women on the U.S. swim team changed from 1984 to 2016? Explain your reasoning. All right. So, the average age has gone up, right? The average age earlier was 18.2, and now it is 22.8. So, average age has increased. And we can get specific and say by 4.6 years. So that means that the swimmers are older now. Are the swimmers on the 1984 team closer in age to one another than the swimmers on the 2016 team? Well, closer in age would be talking about their spread. So we would have to look at the MAD, right? The mean absolute deviation. So whichever mean absolute deviation is higher, that means it has more variability, which means it's more spread out. So 1984, the MAD was 2.2. And in 2016, the MAD was 3. So, the 1984 team was closer in age to each other. That team, the 1984 team, had less age variability. Okay? Because their MAD is smaller. Their MAD is 2.2, whereas in 2016, the MAD is 3. All right, here are the dot plots showing the ages of the women on the U.S. swimming team in 1984 and in 2016. Use them to make 2 other comments about how the women's swimming team has changed over the years. Well, we could say that they've obviously gotten older, right? Which we've already said. But we can say more specifically, the oldest age in 1984, oldest, equals 23 years old. And in 2016 was 30 years old. Right? So they've gotten older. Conversely, you can go to the bottom. The youngest player or swimmer in 2016 was only 19 years old. Right? So the youngest swimmer was 19 in 2016. And in 1984, the youngest was 15 years old. Wow. 15 years old. Okay. So please remember that sometimes two distributions have different means, but they have the same MAD, which means their spread and their variability are the same without their mean being the same. Okay? All right. Make sure you just review your lesson summary, and that will do it.